Look up on a summer afternoon, and you will see something that has no business being there. A cumulus cloud, the ordinary kind, white, soft at the edges, drifting. It looks like the lightest thing in the world. That cloud weighs about 500 tons, which is 100 elephants, half a mile above your head, not falling. That number sounds invented, so let us build it. A fair-weather cumulus, the kind that turns up on a warm day, is very roughly a kilometer wide, a kilometer deep, and a kilometer tall. Call it 1 cubic kilometer. Now, how much water is actually in it? You can measure this directly. Fly an aircraft through a cloud with a probe on the wing, and it counts the droplets as they pass. For a cumulus, the answer is about half a gram of liquid water per cubic meter. Half a gram. That is a quarter of a teaspoon, spread through a box the size of a washing machine. It is almost nothing. But a cubic kilometer holds 1 billion cubic meters. Half a gram, 1 billion times over, is 500,000 kilograms. 500 tons. The cloud is overwhelmingly air. There is just an enormous amount of it. For scale, a Boeing 747, fully loaded, ready for takeoff, weighs about 400 tons. So the small white cloud drifting over your garden outweighs a jumbo jet. And unlike the jet, it is staying up there without engines, without wings, and without using any energy at all. So why does it not drop out of the sky? Because those 500 tons are not one lump. They are divided into roughly 120 quadrillion separate droplets. A 1, followed by 17 zeros. Each one is about 20 micrometers across, a fifth the width of a human hair. It weighs 4 billionths of a gram. And that size changes everything because falling speed does not depend on weight alone. It depends on the contest between weight pulling down and air resistance pushing back. For something that's small, air resistance wins overwhelmingly. A cloud droplet falls at about 1 centimeter per second. Slower than you could watch. It would need more than a day to reach the ground, and it will evaporate long before it gets there. Meanwhile, the air inside a growing cumulus is rising at anything from a few centimeters to several meters per second. So the cloud is not floating. It is falling extremely slowly through air that is going up faster than it comes down. Which raises an obvious question. How does rain ever happen? A raindrop is about 2 millimeters across. A cloud droplet is 2/100ths of a millimeter. That is 100 times wider. And because volume goes as the cube, a single raindrop holds about 1 million cloud droplets worth of water. Getting there takes collisions. Droplets drift into one another and merge. A merged droplet is heavier, so it falls a little faster, so it sweeps up more droplets on the way down. So it gets heavier still. Past a certain size, the process runs away with itself, and what was suspended becomes something that falls. A raindrop hits about 6.5 meters per second, 600 times faster than the droplet it grew from. That is the whole difference between a cloud and a downpour, whether the droplets have found each other yet. There is a second thing holding a cloud up, and almost everyone gets it backwards. Humid air is lighter than dry air. That sounds wrong, because humidity feels heavy. But look at what air is made of. A nitrogen molecule weighs 28 units. Oxygen weighs 32. Average out the atmosphere, and you get about 29. A water molecule weighs 18. And here's the part that matters. In a given volume of gas, at a given temperature and pressure, the number of molecules is fixed. So every water molecule you add is not an extra passenger. It is a replacement. A heavy molecule leaves, a light one takes its place. You're swapping 29 for 18 over and over. Fully saturated warm air is around 1% lighter than dry air. That is why moist air rises. It is why thunderstorms build it all. The entire engine of weather runs on the fact that water is lighter than the sky it sits in. Now, take the same arithmetic somewhere bigger. A thunderstorm cloud is not 1 kilometer tall. It can be 12, sometimes 18, punching against the ceiling of the troposphere and spreading sideways into the anvil you can see from 100 kilometers away. And it is not carrying half a gram per cubic meter. Inside the strongest updrafts, it carries 2, sometimes 3. Run those numbers on a storm 500 cubic kilometers in size, and you get 1,000,000 tons of water held in the air above a single town. For comparison, the heaviest object human beings have ever moved in one piece is an offshore platform of roughly 1,000,000 tons. We treat that as one of the great feats of engineering. The sky does it on a Tuesday afternoon, several thousand times a day, all over the planet, and then sets it back down again. Let's do all of it at once. Add up every cloud, every wisp of vapor, every trace of moisture in the entire atmosphere of the Earth, and you get about 13,000 cubic kilometers of water, collected into a single sphere that is a ball of water 29 kilometers across, more than 3 times the height of Everest, hanging in the air. And it does not sit there. Every year, roughly 500,000 cubic kilometers of water fall as rain and snow, which means the entire supply in the sky is replaced about every 9 days. The atmosphere is not a reservoir holding water. It is a river running through it, and it turns over 40 times a year, which has a consequence worth sitting with. Every single molecule of water in the sky above you right now will have fallen back to the ground before the month is out. Which brings us to the part that is genuinely hard to accept. A cloud is not an object. Watch a cumulus on a still afternoon, and it appears to sit there, holding its shape for 20 minutes. It looks like a thing with edges. It is not. Warm air rises from the ground. As it climbs, the pressure around it drops, so it expands, and expanding cools it. At a certain height, it becomes cold enough that the water vapor it has been carrying can no longer stay a gas, and it condenses onto specks of dust and sea salt and pollen. That height is the flat bottom of the cloud. It is why cumulus clouds have flat bases, all at the same altitude, right across the sky. You're looking at a line drawn by temperature. And those specks matter more than you would think. Water vapor will not readily condense on nothing. In genuinely clean air, it can reach several 100% humidity before droplets appear on their own. Clouds need dust. A perfectly clean sky would struggle to make one. Air enters at the base and leaves at the edges, where it mixes with drier air and the droplets evaporate straight back into invisibility. The cloud stays. Its contents do not. Every droplet you can see was created in the last few minutes and will be gone within the next few. It is not a thing that is there. It is something that keeps happening in the same place. One last wait, and this one is already touching you. Forget the water. The air itself, the whole atmosphere, weighs about 5,000 trillion tons. Spread that across the surface of the planet, and it comes to just over 10 tons pressing down on every square meter. You have roughly 1.5 to 2 square meters of skin. So the air is currently pushing on you with a force of about 18 tons. You cannot feel a gram of it, not because it is gentle, but because you are full of air at exactly the same pressure pushing back out. The force is enormous and perfectly balanced, so it registers as nothing at all. Which is the same answer as last time. The weight of the cloud, the pressure of the air, the motion of the earth. None of it is hidden. It is simply arranged so that your senses have nothing to detect. That is not a flaw in your senses. It is the reason instruments are worth building. This channel takes one number that is impossible to feel and makes it visible. If that is your kind of thing, subscribe. There is a new one every week.